Bierer Meters, Walter Bierer is my stepdad. He owns the company. We're a family company. My brother, my nephew, we have aunts, uncles working at Bierer Meters. Our factory where we build the tools from scratch is in South Carolina. He has 17 patents now, so we have more patents than all of our competitors combined. You guys can go to Bierer Meters, tool training, semicolon, the tool, whatever tool you guys are looking for, on YouTube. We have a YouTube channel. Recommend you guys get on that, check them out if you have questions regarding any of our tools, specific tools. Also, we have Bierer Meters safety training, semicolon, subject matter. We're starting to populate that channel with a lot of safety videos. Some are long, some are full length, some are little chunks, little segments. And you guys are free to use those anytime to supplement your safety program. We're gonna go over tactical safety. We're gonna go over technical training with some of the tools that you all use regularly that is our Bierer products, and one of them will be the PD800W, your wireless phasing voltmeter, which you guys have in your system. We're gonna use this for a lot of the safety training so you all become more familiar with it. And we're gonna be talking about psychological safety. Psychological safety is something that we're intertwining and weaving throughout the presentation from start, middle to finish. And the reason why we do the psychological safety is after doing this for 7 years, the biggest reason that I find that linemen are losing body parts, catastrophic incidences, or death, the biggest reason why is not a lack of rules, Osha regulations. It's not a lack of training. It's actually not a lack of knowledge. What it is I'm finding out that the reason why folks are getting hurt is because they're not following the rules that are written, that they know about. They're taking shortcuts. Maybe they're just not thinking at that split moment. But I want to read you guys this poem by Merrell. It's called "I Chose to Look the Other Way." And it goes, "I could have saved a life that day, but I chose to look the other way. It wasn't that I didn't care. I had the time and I was there. But I didn't want to seem a fool or argue over a safety rule. I knew he'd done the job before. If I spoke up, he might get sore. The chances didn't seem that bad. I'd done the same. He knew I had. So I shook my head and walked by. He knew the risks as well as I. He took the chance, I closed an eye, and with that act, I let him die. I could have saved a life that day, but I chose to look the other way. Now, every time I see his wife, I know I should have saved his life. That guilt is something I must bear, but isn't something you need to share. If you see a risk that others take that puts their health or life at stake, the question asked or thing you say could help them live another day." All right? This is what I'm finding out. This is kind of the unspoken rule. We got the written rule, OSHA, and we have kind of an unspoken rule that we need to speak about, okay? So we're gonna talk about these things. First thing we're gonna go over is your grounds, your TPGs, your temporary protective grounds. And the OSHA regulations are basically what we call scriptures of line workers, lineman scriptures right here. These rules were written because someone died. These rules were written because someone lost a body part and bled. And that's why we have these regulations. These regulations are to be considered a foundation of your safety program, not the entire safety program. So what you all are gonna do is Huntsville, they're gonna use these regulations as a foundation, what I call a starting point, all right? So that's what these rules are gonna be, a starting point. And we're gonna go over lowercase n in 1910.269, lowercase n speaks of your temporary protective grounds. Your temporary protective grounds right here, we're gonna call these a best friend. So if these are your best friend, it's important you're gonna take care of your best friend on that job site. Every day you're gonna take care of your best friend just like you would a normal best friend or even a good friend. These are a best friend. And these regs here, if you go down to number 4, lowercase I, it talks about how the IEEE 1048 and the ASTM F855 are guidelines. So they're guidelines to the regulations. So they're in the regulations as guidelines. And in those guidelines, it speaks of visual inspection. You always, prior to use, you want to always complete a visual inspection, and you're going to verify that there's not any pinched cable or smashed cable or bubbled jacket. If you can see your strands, you don't want to see any obvious broken strands, patinaed copper or blackened copper on your cable. You also want to make sure that you don't see any cracks in your clamps or obvious loose parts, and you want to make sure that you don't have oxidization on your components, especially your contact points. Make sure they're clean. So you want to do that visual inspection. You also want to complete a mechanical inspection. So you're literally going to grab a hold of your clamps on both ends, and you're going to make sure you cannot spin the ferrule, or the ferrule's not loose. Maybe you've got a ferrule that has some contact points that press on hard. You're going to make sure that that ferrule's not loose inside that clamp. You're also going to look at that cable, and you're going to wiggle that cable and make sure that cable does not wiggle. You're going to try to attempt to wiggle, make sure it does not wiggle inside that crimp of your ferrule. Make sure it's nice and tight into your ferrule. And this is awesome, this right here. Okay, this is great. Visually and mechanically, this passes. We also want to look at a date stamp. You should be testing your grounds electrically. We recommend once a year. The guidelines that are written also say that you are to electrically test, but it doesn't say how often. I'm not sure why. I think that needs to be updated. Some folks test their TPGs once every 24 months, very few. Some 18 months, more than not, they test every 12 months. Should have a date stamp. So when you visually inspect, you're going to verify that your date stamp is in compliance with your protocol. All right? So you're going to perform these things, these inspections. After going coast to coast, nationwide, I've gone in the last 7 years, I've gone to utilities, contractors that they were not training their linemen to complete a visual inspection, nor a mechanical inspection at all. Not all of them, but some. And when we got in front of the linemen and started speaking these things, they were like kind of questioning, like, what's going on here? And they would pull the TPGs off their trucks and say, hey, what do you think about ours? And I look at them, and everything that you don't want to see, I'm seeing it. And the reason why I'm seeing it is because they weren't trained that you don't want to see it. So I'm seeing it, and then now they're aware and they're seeing it. The good news is that when we leave these presentations and I leave the service center, they change their work methods. They change their focus as far as making sure that everybody understands their best friend and takes care of their best friend. So that's good. So after 7 years, about tens of thousands of linemen are much safer today than they were before we showed up. So that's one reason why I travel and I spend time away from my wife, because I'd rather be home with her, okay? But I'm not, because you guys need this. So what we're gonna do is we performed a visual and mechanical inspection. This is our once a year checkup, and we're gonna simply test our TPGs. And the chart here that comes out of table 1, page 2 of the ASTM F855 is a table that Walter Bierer, my dad, he actually came up with this table, and they put it into the guidelines. That's pretty cool, all right? I just learned that a couple months ago. I didn't know. All right, so when we test, we're gonna test the TPGs in a parallel configuration. Side by side, we recommend that you all set up a 2x12, some 2x4s on each side make a channel, and you're gonna have your measurements as far as the length of your cable already pre-placed upon that wood, all right, somehow, some way. And because you want your cable to be parallel. And then what we're gonna do is number 2 requires 165 amps. So we're gonna simply go to 165 amps. Can you see that, Amanda, through your camera? Okay, we're gonna go to 165. Here's our amp meter here, using our Variac. And I can feel this current through my hands, and it feels kind of cool. kind of like that fishing trip when you throw that fly rod in. You guys don't use fly rods in Alabama, do you? Do you? Some? Okay. All right. So what we're going to do is we got 165 amps, and we have a 0.28, 0.29 reading here, and the chart requires a 0.24 or less. This does not pass. It probably doesn't pass because I think I have kind of some loose components, because it was passing last week easy at Murfreesboro with MTE. But it doesn't pass, so we got to see what's going on. Why doesn't it pass? So we simply verify everything's tight, everything's clean. It might not pass because maybe you have some corroded cable. You need to cut it back 6 inches or 12 feet till you get to some fresh looking cable, re-crimp it, reset it into your clamp, and then retest. So typically it's just a quick repair, adjustment, okay? So you're always going to want to electrically test. The reason why we test in parallel is because this is going to simulate how you use your TPGs out in the field. How you use your TPGs in the field, when you set up your EPZ, you set up your grounding points to earth, what you're going to do is you're going to verify that point A to point B, that your assembly is in sort of a straight line. You can have some droopage as you go from one conductor to the next, obviously, but you don't want to have any coils. I've seen it to where the folks are using their TPGs, or they tell me, and what they're doing is they create a coil because maybe their assembly is too long for that particular application that day, and they'll create a coil, maybe some electrical tape, because it looks all pretty. And what happens when you do this creates a magnetic field. If this assembly was hit with a potential fault current, that magnetic field would cause the cable to try to run away from itself. It resists itself. If you're in the way of that cable, it's going to hit you. If you got your distance away from your grounding cable, that gets hit with a fault current, that cable, when it tries to escape itself, could escape from itself, hit you with that fault current that it was supposed to protect you from. All right, so what we're going to do is we're going to take this magnet, and we're going to talk about your electrical reality. We're not going to bring up any theory. This is the reality that you all work within every single day, and there's magnetic reality as well, not a theory. And so we build up a magnetic field. I'm going to turn this up to about 300 amps and run this magnet right here. And y'all see what happens here. All right, and I'm feeling some heat, so it causes thermal activity, causes resistance. So they're not smooth, it's not cool, running cool, working well for you. It's working against itself, all right? So you don't want that. I did training for a large utility contractor in North Carolina, and afterwards, one of the linemen came up to me and said, hey, when I'm on 69, I've got my assembly that I use on 115. It's a little too long because 69 kV, the components are closer together, obviously. And he says, I've been coiling up, so you're telling me I can't do that? And I said, I'm not saying it. I said, what did the magnetic reality tell you? That you're to keep doing it or not to do it? You see? And whenever we talk about things, whenever we talk about the reasons why, is you always need to know why. Why are you telling me to do something this way? I want to know the why, the know-how, because understanding equals knowledge, knowledge equals safety. If you don't understand the why at any job briefing, or you're on the job site and maybe there's a change of the plan that was presented to you earlier, and the foreman on the job site says, we got to do it this way instead of that way, like we talked about. That right there is a red flag. And if we don't share the why are we changing it, why are midstream, why are we changing it to go this route? We need to explain these things. Don't just bark out what we're going to do. Don't just yell at why we're going to change. Let's talk about it. Ask questions. Make sure everybody understands. Okay? All right. So let's take that magnet. We'll go parallel. This is simulate how you guys are using out in the field. Okay? Point A to point B. and let's take that same magnet. Just a little hum, a little vibration, but it's a lot smoother. See that? So that's what you want. So when you're working with each other, communication is important. Connecting with one another is important. If you all are out in the field and you get all coiled up, right? It's not going to work well. Your team dynamics aren't going to be smooth. You see how that works? And that affects safety. All right? Bouncing all around, getting all excited with one another, that affects safety. And you all need to remember that. And that's your safety reality. All right? Stay smooth. Your voltage indicators, the safety, the functionality we're going to talk about doesn't matter if you're using our tools or somebody else's tools, as far as phasing, as far as looking at phase to ground voltage, whether the tool is wireless, whether the tool is corded. All the tools work the same. It's just ours are more accurate and a lot safer. And you'll see that. We'll talk about the safety within these tools that we build that nobody else does. All right, we build our tools very safe. You know, we don't have stockholders. Some of these companies, they've been bought and sold and bought and sold, and there's a lot of stockholders that have interests. Well, those interests are called pockets, and pockets hold wallets, and a lot of these interests supersede safety. All right, we don't have that. So safety supersedes everything we do. All right, that's why you get this for free. So here we go. Horn and light. If you have a horn and light, you ever go to a utility or contractor that has a horn and light, you're going to do a battery test. Whether it's a push button, whether there's a dial, you're always going to perform a battery test out in the field. Maybe you have some time here in your line truck, perform a battery test. The battery test on a horn and light, you're going to see and hear. All right, it's really simple. If you don't see, you don't hear, or one or the other, what you're going to do is you're going to take a good known battery, you're going to remove that quick change right here, tap out the 9 volt, put a 9 volt in, reapply your quick change, and then you're going to have your hot stick adapter on the end of that quick change, and then retest. If you still don't see or hear or both, the tool's broken and you need to send it in to us for repair. 20 years from now, your tool's broken, send it in for repair. If your tool's not accurate, needs to be recalibrated, send it in to be recalibrated. We do all that work ourselves, okay? All right, so horn and light. An analog tool, when you all were talking about analogs, using analogs, analog tool, what you're gonna do is you're gonna do the battery test, whether it's a push button, and you wanna see that needle deflect all the way. If that needle does not deflect all the way, or if it's just partial, put a new battery in it. If it still does not deflect all the way, or it's partial, the tool's broken. Send it in for repair. Very simple. A lot of the repairs we get, when we check them out, are simply they didn't do a battery test. Okay? So always do a battery test. All right, we also recommend using lithium. The lithium batteries last a lot longer. They are more expensive, but you get a return on your investment if you use lithium. And you're not changing your batteries as often. So now you're saving on the labor side. So we recommend lithium, okay? Digital tools, I prefer. Digitals are gonna give you more information. Digital tools are more accurate. Digital tools don't have moving parts like the analogs. So you can drop these and chances are it's gonna be okay. An analog, you drop it a few times and those springs start getting stretched, those needles can start bending, things start happening inside. They're like watches kind of inside, the mechanisms all moving and stuff. So digital I prefer. So digital, the more information, remember, battery tests. So the digital actually gives you the battery voltage, which to me, that's more information. If you see 7.2 volts, change out your battery. Our operating instructions say 8, but you can get a little more time out of it, a little more life out of it, 7.2, okay? So this is good. We just, what's that?
Say that again on the voltage when you change battery.
Yeah, so if our operating instructions say 8 volts, like on your PD800W, your wireless phasing voltmeter, but I use them down to 7.2, they're still accurate. You can get a little more time out of that battery, all right? So there you are. So the VD1000X, this is brand new. We came out with it. This here does all your primary voltage, underground, overhead transmission, and it does have a new secondary position. So it's wireless and it's pretty accurate on secondaries. So this tool here takes care of the whole gamut of what you guys would ever work with. All right, we just came out with that. Okay, so that's kind of cool. Also, we do have our own components, our own ferrules, cable. We have our own clamps now, Miss Caroline, in case you didn't know, probably didn't know. We have our own forgery, our own molds. So we're coming out, and we just had these high voltage tested a year ago, and everything passed great. All the high current test lab. And they're nice. They're 30% stronger clamps than sand casting. And they're a lot smoother looking and more professional looking. All right, so on your meters, we're going to talk about an equation here that you always want to remember, and that is X plus Y equals Z. This is an equation you guys always need to remember, and going down the line, you're going to be sharing it with a lot of folks in your career, because this is a super important equation. That equation X is your conductor. Whether it's energized or de-energized, X is the conductor, plus Y. Y, remember we said, well, you need to know the Y behind whatever, what the thing is. The thing is your voltage indicator, so Y plus Y, Y. How does it work? So the Y behind the tool is when it makes contact with the conductor, it couples with the capacitance, the tool the components look at the current that's flowing through it in relation to the ground plane, right here. That's the ground plane, all right? When it does that, it gives you the Y, it gives you the voltage indication, whether you're in phase, out of phase, phase to ground, whatever you're doing with it, looking at the voltage, the potential is giving that to you. That's the Y. Equals, we've always think, well, it's going to give you that indication. What's that nominal voltage on that conductor? We're in that pad mount. You guys are on a capacitive test point. You guys use capacitive test points? Do you? Okay. Or a feed through. What's that voltage, that potential? So either way. So equals, it's always equaled safety. Not your voltage. Always safety equals Z is safety and accurate information gathering. So you could use these tools in an unsafe manner. And if you use them in an unsafe manner, then you're going to get inaccurate information gathering. Yeah, you'll have an indication, but it's going to be like, that's not very accurate. Why? Why is it not accurate? Well, you know how the tools work. So you're supposed to let the tool look at the ground plane here. Maybe there's a ground plane here. Maybe it's a closed cabinet. And so it's going to read high. Maybe you're short sticking the tool, and you're not supposed to be short sticking, so it's looking at you as a potential ground, so it's going to read a little high. So you always got to get safety and accurate information gathering is the Z. X plus Y equals Z. You all get that? Always remember that. Okay? All right. So keep your probes clean. No calibration stickers, dirt, grease, oil, nothing like that. No paint, no markings on your probe. Hot stick wipes work great. Keep your probes clean. We have that prevents external tracking. Because remember, the components, when they look at the current, the components are energized, right? They have to be. If it's going to give you that voltage indication, the components must be energized. So we put epoxy inside the probe. There's resistors right here at this probe tip. We put epoxy, the epoxy, we bake it, and it helps keep the resistors safe from bouncing around in your truck, coming loose. Also, the epoxy inside the probe keeps the external elements like moisture to come inside, where you could possibly have an internal track. Cut open a competitor's probe, and you'll be surprised what's inside a lot of the probes. Mostly air. Okay, and the wires kind of bounce around inside. Okay, we don't do that. So they're really safe, very strong, very robust, these tools. So right here, that line limit. Remember we talked about the resistors. That line limit is to remind you that that's where the resistors are located, right there. The resistors in the tool help keep you behind the tool safe from that primary potential. And it helps keep the tool safe, those resistors, from the primary potential, okay? So always remember that's why that line limit's there. So you're gonna take that line limit, that knowledge, and you're gonna extend that knowledge, you're gonna extend that line limit in your mind, in your imagination, and you're gonna create a sphere around your tool. Around the sides, you're gonna create a sphere around the back, other side, bottom, and top. And in this sphere, we're gonna call this your air dielectric. We're gonna call this air dielectric, your air gap. All right, you open up a switch, you have a confirmed visual air gap, you're gonna have a confirmed visual air gap around your tool. And we're gonna call her the air dielectric. And you wanna always take care of her. She's your other best friend. We're gonna talk a lot about her, and you gotta take care of her. The call we get more often on any of our tools, as far as a complaint, is they were using the tool, maybe in a tight vault, a tight cabinet, there was a bleed wire, maybe they were in a substation, and they were making contact with the conductor, and there was another hot phase next to the meter head. Flashover. There was a static wire inside that cabinet. Arc flash. Because no one trained them, no one taught them to protect that tool. No one let them know that the tool's energized. No one told them that. They just were handed the tool, say, hey, go to this job, we need to get some phasing, we're gonna balance the load. Before we throw in that switch, we're gonna make sure that we got the same phase. And no one told them how the tools work, all right? So always protect your air dielectric. Keep her safe, keep her there. I get a call from a line worker in Illinois, and you guys see this probe here? This is a pole, right here, that's a pole, all right? There's 3 phases here, there's 3 phases running here. The lead lineman called me up, and he proceeded to tell me he was using an analog, like right here, and he was getting 13,000 volts on 7200. And he told me that our tool was no good. He just had it calibrated and it's broken. And then he needs to send them in, and he's kind of getting tired of sending them in back and forth. And he's like, we're losing confidence in your tools. So I told him, I said, look, lead lineman you're not gonna argue with, obviously. So I told him, I said, I'm gonna get a ticket, fly out, and give you some lineman safety and tool training. We're gonna take your Baroque tool, you're gonna go to that same scenario and use it, and let's see what the tool says after the training. So we did. A couple weeks later, I was out in the 8 inches of snow, northern Illinois, and we did the class, the indoor class, which wasn't so bad because they had a heater. And then we went outside in the snow. He got in the bucket truck. When he got in the bucket truck, here's the corner pole here. He got in that bucket truck, and he made contact with the conductor in that broke tool, and he got 7,400 volts with a wireless analog. That's pretty accurate, all right? So he got down out of the bucket, and he proceeded to tell me everything that I already knew he was doing improper. I knew because he was getting 13,000 volts on a wireless analog tool, I knew that he was a living, breathing phasing meter, wireless, out of phase. He was, okay? He became the tool. And how he became the tool is he was short sticking when he called me. That's improper body position. He was short sticking. He wasn't protecting that air dielectric, because now the equation became X plus him plus Y equals no safety and inaccurate information gathering. You see how that worked? Because he had improper body position, short sticking. Also, what he was doing was when he was using this tool, he had his back to the enemy. That potential. Whenever you're working hot, I like to train it when you're working hot, that conductor, even though you're making good money working with those conductors need to be considered your enemy. And he had his back to his enemy. And what was happening is he was coupling with the capacitance of that conductor behind him, It was flowing through him, the capacitance, flowing through him and across his gloves, through the tool the opposite direction that it was designed for, if you use it properly, and it was making contact with the conductor. That potential was flowing through the proper way it was designed for, and he was phase to phase, out of phase, getting 13,000 volts. Pretty accurate wireless phasing meter, his own body. So he had improper body position times 2. So what he did is he simply kept the bucket truck in the same location when I came out there, exact same location, and the tool stayed in the exact same location. He simply adjusted, and he had proper body position. He had that visible air dielectric, his best friend, between him and the conductor. Okay, you hear about MAD, right? Even if you're close to that MAD, you're going to be coupling with that capacitance some degree, measurably so, even if you're close to the MAD. So just remember that. And now he has this air gap, visible air gap between the meter head, which is energized, and his hand, his gloves. We recommend 36 inches. Some folks go 31 inches. All right, Florida Power Light does 31 inches. I prefer 36. Most folks are trainer linemen 36. We recommend hand guard. You can get a hand guard to go around your stick. That's already measured. It's there for your use. You can use electrical tape. Some folks say, well, we can't afford hand guards, so we use electrical tape. That's fine. But it gives a chance. If you have a hand guard or marking, it gives a chance for Mr. Andy, if he's on the ground for this day and you're a journeyman up in the bucket, it gives him a chance to visually inspect what's going on with you. And he can confirm that you're working safely. See? Isn't that cool? All right. Another thing is you don't want to ever do is tool glove right here. Maybe you do have that capacitive test point. You don't want to put the tool in your gloves and go to the capacitive test point with your gloves on. This is not safe. Never has been safe. The equation is X plus Y plus U equals unsafe, inaccurate information gathering. Also get a call from a guy, horn and light. He was up on a corner pole. He was in the bucket. Switch was open. And he called me and he said, hey man, I'm getting a false positive. Give me the video, send me the video. So he's in the bucket, Louisiana. So he must have ate some bad gumbo maybe. All right, his stomach wasn't feeling so good. Too many mud bugs. All right. So he was shot the video, switch was open, clean as day. Provable, visible, everythingable. And then here he is in the bucket truck, the horn's going off. And the horn's telling him that conductor, that cutout was open, that conductor is energized. So let me ask you guys a question. I got my back to the enemy, I'm short sticking, and here's the video he's showing me. And that horn and light's going off, and that conductor is telling me that conductor is energized. The switch is open. Is that conductor energized or not? Is it? It is. Through my body, because I have improper body position. All right? I'm coupling with the capacitance. It's flowing through me, across my gloves, through the tool the wrong direction. The switch is open, but the tool's saying, hey, that's energized. Whenever your tools give you a funky reading, and you know better, the tool is trying to tell you, maybe you don't know better. The tool is telling you, maybe you need to stop, take a pause, and maybe you need to readjust something. Just pause and think about your situational awareness. Where are these components? Where's your body? This is improper body position. Oh, that's right. So I gave him a quick lesson. He gets back on his stick. He has the enemy in front of him. Never have the enemy in the back of you, if at all possible. Never. And he's back on his stick. He makes contact, and the tool says, yep, that's de-energized. Okay? Y'all see how that works? If you're using your tools and you're on a vertical stack, make sure that your tool is perpendicular to the conductors, your long sources, above and below, and perpendicular to that potential. Try not to get your tool, if you bring that tool at an angle to the long source, what happens is that tool becomes the same potential. Your readings start dropping. Accuracy dies. If your meter head starts getting close to another phase, below or above, that meter head your accuracy is not going to be as good. All right? So get perpendicular if all possible. Maybe my wrist represents a pole and there's a pole ground. Well, maybe I should get just a little bit, a foot or two further from the pole, and I'll get a better accurate reading. See how that works? If you're in a substation doing work, where are all those ground potentials around you while you're using your tool? What about the other potentials? They're sometimes pretty close together. So keep an eye on all that. Proper tool position, it's important. Proper body position is important. I had a gentleman, journeyman lineman, probably 25 years. He was gray-haired, and I did training in South California, large utility in California. And what happened is he was used to going to the capacitive test points with his gloves on and his tool. Like this tool here, Hornet Light. He was using a Hornet Light. And no one ever trained him that this was unsafe. No one ever trained him that this was unsafe, ever. So what he did is he used his gloves, went to that capacitive test point. Then one day, what he did was, you know how guys are. We're kind of thick-headed sometimes, numbskulls, and we're not paying attention to our job. Tool gloving is unsafe. But one day, one time, what he did was he took that tool barehanded. No one ever trained him that if he makes direct contact with the conductor, that tool becomes energized. He didn't know. He didn't know current was going to be flowing through that tool. He didn't know. No one ever trained him. When he made contact with that capacitive test point, which is about, 10% of your nominal voltage, flowed through the tool. Good news is that those resistors at the end of the probe tip help trim that down to a lot less than 10%, but he did get popped with a couple hundred volts. He did. And should you be surprised? You know how the tools function. So you all know that that's to be expected. And that's what happened. He got hit. Okay, scared him a lot. But you know what's wild about that is that utility, at least at that time, they did not have a program in place to where they had once a week meetings to where we can discuss incidences safely, without retribution, without worrying about losing your job, without demotion, without getting a write-up. They didn't have that in place. So he never told anybody about that incident. So all his brothers, all his line crew that he worked with, they never knew that that was unsafe because he never was able to share safely his experience. That's horrible. That is horrible. And that policy is rampant in our industry, and it needs to stop. I was doing training January in Trico Electric Cooperative on my way to APS, Arizona Public Service, doing training, and then Southern California with all those utilities down there in January, this last January. And I got to Trico, and Mr. John Dungan, the safety guy there, he said, "Hey Brent, before you start, we want to do a 15-minute tailboard, safety tailboard." And I was like, cool. I get to watch this, and I get to experience what Trico does in their tailboards. And you know, that was so cool, seeing what they did openly. And they opened the floor. They talked about some things, this and that. And then they opened the floor at the end for anybody to freely share an incident that took place over the last week. Two linemen stood up, and they openly, freely, unashamedly shared their incident that took place. And everybody respected one another. Everybody didn't look down on them and you know, make fun or laugh or anything. Everybody respected those two guys for sharing. And the reason why they respected it is because they had an open policy to share incidences freely without any worry of anything coming down on them. And the reason why they did that and do that today, the reason why is they learned something. They learned that if we share our mistakes, then that same mistake that we experienced, whether it was intentional or maybe a shortcut, but we didn't think it was going to happen, but it did happen. But now we're going to share that so that our line team within our utility, nobody experiences the same thing. And they are very safe. And it's amazing. And they're a team. They're really truly a line team. And no one's afraid about nothing. Okay? Because you guys, every day of your life, you guys make mistakes. That's our human nature. And that, until we leave this right here, this temporary tent, until we leave this temporary tent, you will always make a mistake every single day. Sometimes they're big, sometimes they're small. Sometimes your mistake is intentional. Sometimes your mistake's a shortcut. Sometimes it's ignorant. You made a mistake ignorantly. You didn't know it was a mistake, but you learned later it was a mistake and an incident took place, whether big or small. And you're going to always make mistakes. But we need to share with one another, and we need to come together as a line team. That's what's lacking in our industry. And that's why a lot of these guys are getting hurt. Because what we do is we take this organism called you guys, which are electrical charged beings, and what we like to do, instead of completing a circuit, all right, me being here today, I help complete your lives, all right? Me being here today, you all help me complete my life. It's not that I'm Sharon and Mr. Andy here, he's an apprentice. No, we're all equal level here. We're all equal. And Mr. Andy helps complete me, I help complete him, and vice versa with each other. And what happens is, if we live this life and we get an ego, or we get some sort of attitude, what happens is we start putting up blankets. We start putting up line hose. We start insulating and isolating ourselves from one another. And we don't have that communication like we're supposed to. And that's dangerous. If someone in your crew has an attitude, that's dangerous. If you guys have a tail brief, if you guys have a safety meeting, and you got this journeyman lineman that's got 1 year left, he's the best journeyman lineman that you guys have. He knows his crap. He knows how to throw a pole in. He knows how to restring, reconductor. He knows how to do all this the very best. But he's in the back of this safety meeting with his head down, his hat covering his eyes, on his phone. He might be the very best, but he also could be your very most dangerous person. Think about it. This is what's going on. I hear about it because of electric culture, safety, all these speakers. I know these guys. Caleb right here, Caleb Thompson, I know him. I know the things that he experiences. He tells me his stories. This guy right here, Mark Todd, these both are going to be speaking next month. You guys could get this for free. We got like 19 videos now. 19? No, 18, because this is 19 and 20. We got 18 videos now, all recorded. And these guys, they tell me all their experiences. Every speaker tells me their experiences. So I live by, when they tell me these things, I'm listening. And their experience, I'm living. And I'll share some, I've been sharing some of these experiences already with you today. You just don't know it, okay? It's kind of cool. It's a blessing to be around these guys. Because I'm getting fed, and it's almost like, man, this is kind of selfish. But it's really cool. So I get to give you that too, all right? So we're going to help each other. So complete the circuit. Don't isolate yourself with attitude. Don't isolate yourself with ego or pride, okay? Because that'll get somebody killed, maybe you. All right, guys, we're going to continue on. I do want to give a little, I like to mix this up. You know, the sine wave, right? You got that sine wave is that 0 point, and you got that positive, you got the negative. And so I'm going to share a little psychological safety to you guys. And these stories every story I share with you is a real thing that happened. Several years ago, there was a lineman that he was just topped out. Just topped out. No longer he was an Andy. Just topped out, journeyman lineman. And he just got married to a beautiful wife. Just got married. He was an hour away from signing on his first home ownership with his new wife. He's got the bigger paycheck. He's got everything. He's at the top of his world. All right. And what happens is, remember I talked to you about as far as distracted line work. All right. Our attitude, pride, maybe our joy. Maybe even your joy. If you're focusing on your joy, how good your life is, you got to be careful, because that's distraction. That even is distraction. All right. And what happened was, he's working in the bucket. He's working hot. He's got some cover up, some hose, maybe not as much as he should, possibly. Maybe he's left a couple components in his truck still. All right, but he's got to get this job done. It's the end of the day. He's hot, he's tired, he's hungry, and he's going to sign a house. He's got all these dynamics in his head. He's got the new wife, his new paycheck. He's thinking about maybe a new truck after they get the new garage and the new house. So he's got all these dynamics that are going through his head. And he bumps the primary as he's holding the guide wire. He bumps the primary. Everything turned black. He wakes up. He wakes up in the hospital. He looks around, and both arms are amputated. Okay? Both arms are amputated because he wasn't focused on the task at hand. He knew exactly what he had to do. He went through all the safety meetings. He went through all the training. He had the experience to perform and be successful. But what kept him from that success was simply his psychological awareness. What was in his head? This is really important, and this is what's going on. And in 3 months, that same guy, journeyman, just topped out. He lost his job, he lost his wife, and he lost his home. In 3 months, he went from here to here, the exact opposite, because of this. Your woman at home, you need to think about her, your kids. You need to think about them. She needed a husband at the end of the day to come hug her. She wanted a husband at the end of the day when they started having children to wrestle, to throw the kids up in the air and catch them. Throw ball with them. That's what she wanted. That was her expectation when she married him. But all that disappeared. Her little world got destroyed. And for her, it was the right thing to do to just leave him. That's how she decided, and she did it. His job, they couldn't use him no more. He couldn't do the job. Couldn't do the job. He couldn't do it. Okay? He lost his job. Couldn't pay the house, lost his house. This is what's happening. These are true stories. Okay? You guys got to not think of yourself. When you think of yourself, that is when you are in the danger zone. When you think of yourself, you're putting everybody around you in the danger zone as well. And there could be an incident, it could be severe, very tragic. All right? So when you're at the job, think about the job. Think about each other. All right? True story. Okay, so these OSHA regs right here. These OSHA regs, not that one. Not that, I could pull that up. You guys couldn't see it anyways. Okay, that's what we'll do. All right, 1910.269, talking about your best friend, lowercase n, temporary protected grounds. Prior to installing, number 5, go down to number 5. Prior to installing your TPGs, you're going to verify, the regs say, using your tester, you're going to verify an absence of nominal voltage. That's what it says, open test ground. All right, so what we're going to do is, because you guys are using tools that are accurate enough to verify an absence of not only your nominal voltage, but an absence of induction, we talked about that, and you're going to verify an absence of backfeed. You're going to take the OSHA regs that say an absence of nominal voltage, and you're going to start building a wall and a roof over your safety program and get past just the foundation. You're going to add to it. because you guys have safer meters. You have more information. So we're going to create a safer environment by using your tools and training all your folks to verify an absence of the system voltage, induction, and backfeed, all three, every job, every time. Does that make sense? Okay, non-contact tools. If you ever go to a contractor or a utility that uses non-contact tools, you need to have a serious talk with the tool man and the safety guy and everybody and tell them that they need to chunk those tools. Chunk it. When I moved to South Carolina 9 years ago, I came from Arizona. I never heard that word, chunk it, in Arizona. I spoke Spanish half the time. We don't say chunk it. But chunk it just means throw it away. Okay, in case you guys don't know, Alabama, you guys should know that too. Just throw it away. Non-contact tools, you're gonna get false positives, false negatives. If you're on, 19.9 underground, you're gonna read 2 feet away, you're gonna read 69,000 volts on 19.9. That's not accurate, because we're the only manufacturer that discriminates with your tool, your PD800W, and your other tools, your voltage indicators, all of them. We discriminate. When you're working close to the ground plane, we got URD, underground, because you're close to the ground plane. No one else does that. If you're working overhead with your PD800W, you want to verify the potential, you go OH, overhead, because you know how these tools work, and you're far from the ground plane, so you want to make sure the tool knows that, so it's going to be more accurate. Okay, so remember that. No one else does that. Non-contact tools, no good. Very dangerous. All right, so what we're gonna do is we're at this job site, and you guys hear that generator going. So we're gonna energize these pad mounts. What we have here is we have a 3-phase overhead line, okay? Pretty close to looking like one. So that's what that is. We have some 3-phase cabinets. So what we're gonna do is we're gonna take our PD800W, put it in URD, because this 3-phase overhead line is pretty close to the ground plane. Let's say we've got capacitive test points. Direct contact, energized, okay? So you're hot. Overhead line, non-contact tool is gonna show you all kinds of numbers out here, about 69,000 volts even. This tool is silent, direct contact. We got about 20,000 volts. Your PD800W wireless is pretty accurate. We're on 20,000, it's close to 20,000. How often do you calibrate? If you use your tool on a live known voltage source and your tool is not accurate, you have proper tool position, you have proper body position, and your tool is not accurate, then it needs to be recalibrated. If you use your tool properly, proper body position, proper tool position, and on 20,000 volts, instead of seeing 20,000, or your 40, was it Joel 4,200 in those volts? 72. If you're seeing 4,000 or you're seeing 12,000 on 7,200, your tool is not calibrated. It's that simple. Okay, so we have to say something. We recommend once a year calibrate your tool. If I'm using this tool for 20 years and it's accurate every time I use it, because I have the lineman safety and tool training, and Huntsville trains our guys this way, and that tool is accurate for 20 years, it's calibrated for 20 years. All right, so you guys got to make your decision. All right, so what we're going to do is we normally teach. Yeah, absolutely, Amanda. Absolutely. We normally teach in the utility industry, contracting, open test ground. Okay? We open, lock out, tag out. We have a confirmed visual air gap, and then we're going to test and then ground. I don't like teaching that. I like to take my time, and I like my guys out in the field, I want them to be safer than any other guys, because I want to keep them on my team until they retire. All right? Because I want to see their families grow up. I want to see them enjoy life. It makes me happy that they enjoy life. So I'm going to create an environment with the capacity in this environment in Huntsville Utilities. We're going to create and have this capacity to where we can fail safely. Because we're always going to make a mistake. Don't know when, don't know where, but we make mistakes. So if we fail, we're going to create a safeguard. We're going to create a system that we can fail safely. So what we're going to do, instead of open test ground, we're going to test first. The reason why we're going to test first is to verify your tool's working properly and accurately on a live known voltage source. We did the battery test. That doesn't test the tool on a live known voltage source. It's just a battery test on anybody's tools. There's no transformer stepping up 9 volts to high voltage. It doesn't exist, anybody's tools. So we're not gonna open the switch. We're gonna take a little more time here because we wanna get more knowledge, more understanding, and we have more safety, because that's what we're building here. We're building a capacity where we can fail safely, all right? So we test first. The other reason why we test first, and this won't be written in the regs, the reason why we test first is because Mr. Andy and I, we're on this job site, this overhead line job site here in Huntsville. Every job site that Andy and I go to, we always talk. Andy, you got my back? On every job site. And he asked me, we talk about it. Hey, Brent, you got my back? It's just a little reminder. Where's your head? Before you got asked that question, where was your head that moment? Huh? Where was it? So we always talk to each other. So we let the tool tell us, hey, we're going in. There's fire in the wire, and this is what we live with, and this is what we do. You got my back? This is real. And we talk about it. So we're gonna test hot. Next thing we're gonna do, after we do that, is we're gonna go ahead and open that switch. Okay? We open the switch, we got it locked out, tagged out, we got it confirmed, we know what's going on. We got the guys at the control center, they got everything safe, they know what's going on. They're gonna have a change in shift, a shift change, and that new guy, he's gonna understand everything that guy that's leaving his job just did for you out in the field, for me and Andy, okay? He's gonna understand it 100% completely. There's no accidents, because we're a line team. We test, right? The tester tells us 3 things, proves, determined, 3 things, that there's no induction, there's no backfeed, there's no nominal voltage, correct? All 3. That's how we learn, that's how we stay safer, all right? Then what we're gonna do is the 4-step. The 4-step, and this is sweeping the nation. This is really cool, and I feel really good about this because everybody's starting to go to test the tester. You're gonna test your tester on a live known voltage source to make sure it was telling you the truth. Make sure it was telling you the truth. All 3 of those voltages were absent. If you're working a storm, if you're working an outage, and you do not have a live known voltage source, how do you test your tester on a live known voltage source? Because you guys always do and will. See what I'm saying? Because you're building a better safety capacity to fail safely, and you won't fail. So you test the tester. Now that we test the tester, 4-step, it proves the tester is working. Now we can safely ground. See how that goes? That's your 5th step. All right, so this is another thing that's picking up steam throughout the country, and it's cool. Another cool thing is if you work in those tight environments and you visually inspect your work area, and you know that if you work and use a tester of any sort, that there's a ground plane in close proximity, maybe a cabinet, a vault. Maybe you're on a feed through, and this side of the feed through gets you really close to that ground plane, that potential ground. Or you're working, like I said earlier, in a substation, and you're gonna make contact with the hot bus here, and there's a hot bus to here. Well, you know that you can have a crossface because you know how these tools function, and you don't want that. So what you're gonna do to prevent that, to mitigate, that scenario is you're going to simply use a 0 ohm extension. 0 ohm extension equals arc flash prevention. This is the call we get more than any other call in the past. There are hardly any more because we educate them. But they say, hey, your tool's no good. My guys were using your tool and we had an arc flash. And it's like, oh, okay, show us the picture. And it's always the same thing. Pictures are always different, but the scenario is always exactly the same. There's a hot bus nearby, or there's a bleed wire nearby. Some are actually touching the housing. So it's very unsafe. And they had an arc flash. We do the training, and we never get those calls from those utilities that receive the training. We never get those calls ever again. So let's see what it looks like with the 0 ohm extension on it. And you're not going to use these in your kit often, but when you need them, you have it. If you're phasing with the PD800W, and maybe you're phasing, you got three bushings really close together, that meter head could get confused. So get the 0 ohm extension, get that meter head out of the corona of those other phases, and it won't get confused no more, okay? So get it uninvolved with coupling with that capacitance and get it completely focused, the tool focused on just this conductor, that phase, okay? So let's go back to this overhead line. All right, notice the voltage is lower now. Remember we were around 20,000 volts? Now we're closer to what, 19? About 1,000 volts difference, bouncing around a little bit. So why are we lower now? Why? Remember how the tools work, the why of the tool, right? There's some things that come in here. So what has changed physically from before without the 0 ohm to now with the 0 ohm extension? Two things I want you guys to focus on. What physically has changed? And it's all in part of the functionality, the why. What has changed? Distance from? The conductor, exactly. That has changed. Distance from the source. Okay, that's one thing. And then distance from, one more. Remember? The what now? Well, yeah, the ground plane, exactly. So that's good. So we have the difference of the potential happens to be the ground plane, right? So it's further from the ground plane. So our numbers are lower. And we expect that because we know how the tools function. If the tool's closer to the source, if the tool's closer to a ground plane, the numbers are going to be higher. All right? I got gloves on. I'm doing training for a week, having linemen go through. We are using this pad mount right there as test, open, test the tester, ground. Okay? Because I won't train open test ground. So we're doing that. And two linemen came up and said there was this incident that took place. There was an arc flash. And what happened was is two guys were out in the field together, working the elbows, working the cabinet hot, and they knew it. One guy was on a stick. One guy was on a stick working the elbows. He had his air dielectric. See that? His best friend. He was on a stick, back of the stick, safe. And the cabinet was loose from its foundation. And his buddy went to the cabinet with his gloved hand, put his gloved hand on that cabinet, and got arc flashed. Okay? So what happened was when he saw that cabinet was loose, just remember you all need a good foundation in your life. That's important. When he put his gloved hand on that cabinet, he got rid of his air dielectric, didn't he? He got rid of his air dielectric. What he did is he trusted a good friend. And sometimes a good friend can let you down. And he kicked it, when he trusted the good friend, he kicked his best friend, that air dielectric, to the wayside. This day was different than other days. He was soaking in sweat. He was in the swamplands basically with his body, all his clothing was wet. It wasn't a dry day. And so those environmental conditions change. And that's part of your accurate and detailed job briefing is, hey guys, we're going to be sweaty out here today. It's not like when that weirdo guy came from Bierer Meters and did the training on that nice, cool, dry day last March. So we know those red lines that you do work with, when you work hot, there's red lines. That's why they come up with MAD. And those red lines are manipulated. Depending on environmental conditions, they get manipulated, okay? So what happened was, you guys see those numbers right there. I got gloves on. Watch these numbers. Ready, Amanda? Watch these numbers, okay? What are they doing? They going up? Does that make sense? I got gloves on, but you know what electricity does, don't you? You know what it does. It gets excited. When that electricity, what does that job of that electricity do? It wants to go back to ground. It wants to go back home. Okay, it's generated, but it wants to go back home. Like you guys. You guys are generated, you get spit out the door, you got a cup of coffee, but at the end of the day, you want to go back home. Just like that electricity, okay, after the generation. And that's what electricity does. And when I get close to that electricity with my body, if I'm working safe, if I'm working unsafe, if I'm taking shortcuts, irregardless, that electricity, when it sees the ground plane, that electricity gets excited, doesn't it? And those electrons start getting happy. They start dancing around a little bit, huh? And if they dance around a little too much, he put his gloved hand on that cabinet and he got arc flashed. And they went home. He didn't know where the red line is, and you guys don't know either. But depending on your equipment location, depending on your body location, depending on environmental situations, all these things are dynamic and they're always moving. You can't see nothing. Maybe your body you can see, but a lot of things you can't see. What's going on in that guy's head? You don't know. But you need to know. Let's talk about it, okay? So they said in that incident report that the reason why he got arc flashed is because of rat piss in the cables. True story. So what they did is they said, oh, it's because of rat piss. So what they did is they closed the book. Think about this. This is where we're at. This is what needs to stop. They closed the book on safety and on knowledge and on understanding and said, oh, it's rat piss. Book's closed. Some money went to the family. He got out of the hospital, didn't lose any body parts. He's back at work. But no one learned nothing. They didn't talk about their electrical reality at all. That's freaky. That right there is flat dangerous. You want to have more incidences? Keep the ones you have silent, and you're going to have more. A lot more. Okay? Just don't talk about them. Okay, well, we have more. Well, why did we have this one a year later? Oh, we had another incident. Why? Because you didn't talk about what happened 2 years ago. You see how this goes? It just keeps happening. And that's what happens. So in 2004, OSHA came together and did a T&D, you might know this, Joel, a T&D partnership in 2004. You ever hear about this? This is a true story. This is good stuff to know. But you guys have a little bit of this on video. And what they did is OSHA, when it became OSHA, up until 2004, they had about 5,000 reports, documentations of, not 5,000, 500 individual deaths that have happened in the utility industry, all right? And they came together in 2004 and they discussed, what do we need to do about this? Because it just keeps happening. What do we need to do? Do we need to make MAD further out? Do we need to increase MAD? And they went through all these documents, and you know what they found? This is a true story. They found that the reasons why these things were happening was not because generally, this is general, there was a couple situations, but generally speaking, the reason why these events were happening was not due to a lack of PPE. 2004, it's almost 20 years now ago, was not due to a lack of PPE. It was not due to a lack of quality of their PPE, holes in their gloves or cracks in their hoses. It wasn't none of that. It wasn't due to an absence of proper training. It wasn't due to none of that at all. Zero. Generally speaking, the reason why these incidents were taking place is because the guys were not following the rules. They were not following their company's protocols, their safety. They were taking shortcuts. They already knew that they knew how to do these things properly, and they did not do them properly. And what happened is, 20 years ago, they came up and concluded, basically without saying it, okay? Without admitting it. That's what freaked me. I'll admit it for them, is the reason why these things were happening generally, typically, these deaths, is because the guys were not paying attention. They were distracted, preoccupied, they had pride, they had an ego issue, they had attitude, and that's just how they did their job that day versus another day, and they were killed. So we go 2023 today, and you know we're losing one lineman to death about once a week now. It's getting worse. Our safety is better, but the deaths now are they're getting out of control. Almost one a week. Just lost one, last week, right? Predictability. Can you not predict on your job? When you do things, do you not predict? You guys are gifted. You guys, inside of you, you have unbelievable powers as far as knowing ahead of time what may happen before it happens. You do. And you need to pay attention, and you need to talk about it, and you need to speak up. You have every right to stop a job if you are uncomfortable or have that gut feeling. That gut feeling is not a gut feeling, it's your gift. Pay attention to your gifts. They are real. They are real. Pay attention. It's not a gut feeling. It is your gift, and you better pay attention and speak up. So what happened was, there's a conductor laying across the road, guys on the pole, putting the conductors back together, working on the conductors. A car runs over the conductor flips up in the wheels, and the car drags that conductor, pulls it, the lineman's on the pole with the conductor, it flings him off, lickety split, into the dirt head first. Instant death. Could that not have been predicted? It's in the dang road. The conductor he's working on, which you always want to consider conductors a possible enemies, right? If it's energized or not energized. If you are working with a de-energized conductor, but you're doing it unsafely, promiscuously, maybe, as far as safety goes, right? Something could happen, and it did. That could have been predicted. See this box right here? This box, I was at Georgia Power. About 3 weeks ago doing training with Georgia Power. And I put that box there. And I thought to myself, it's possible that during this training, that box might fall. Does it look like it could, possibly, to you all? It's not normally how you'd want to place a box, right? It may fall. It's possible. And sure enough, I was walking across the top of the roof to put up that sign. The vibrations, remember, everything's dynamic, right? The vibrations caused by me walking on that trailer was just enough to cause that box to fall on the ground, and it did. After I just got done thinking, like 30 minutes beforehand, that it could fall. Because that's a gift I have, okay? And you guys have it too. So use your gift. Save a life. Save a life. All right. So, Mr. Andy, you ready? Glove up. How much time do we have before 10:30?
It's 9:50.
9:50? Nice. Good. All right. So Mr. Andy is going to use our PD25, which is a great tool for your tight confinement areas, working in tight confinement scenarios, which you need to get in your hand because it'll end all inaccuracy because it's corded. So what's going on out here doesn't matter. It's not wireless. So you got a true phase to ground reading through the cord. Remember how they work? The wireless, it looks at the current in relation to the ground plane through the air, right? The corded looks at that current in relation to the ground plane through the cord. Nothing's gonna touch this. It's a very accurate tool. True RMS voltage plus or minus 1%. You can use this to de-energize capacitors. Maybe you just high potted a cable. You can use this to high pot that cable with. You can verify your regulator neutrals in the neutral position or not. You can also use it to test lightning arresters. You can use it, obviously, phase to ground. What's the potential of any conductor starting at 1 volt? Okay? You can also phase to phase. Capacitive test point phasing. Primary, overhead, underground, everything. We call this a multimeter. It reads AC and DC voltages. You can also use it with the 100 volt battery pack that's in this kit. You can use it to identify cable, maybe new construction. You put 100 volts on the secondary probe, which is right here. You put that 100 volt battery pack, you take the meter head, and you go to the other side of the cabinet. When you see 100 volts, that's your cable. You can identify. It's a great tool. You can also use it with a phase sequence adapter. You can find your leading phase in the field because it's so accurate. All right? So you ready, sir? Okay. All right. That's good. Here you go. Mr. Andy. All right. So what we're going to do is we're going to take the secondary probe to ground, which is going to be over here, the trailer itself. So I'm going to come to ground with the secondary probe. The cable, we're the only manufacturer in the world that builds this cable custom. This cable is a cable inside a cable. When you use this tool, you can use this tool with the cable on the ground while you're phasing. The cable can lay on a metal box, maybe a cabinet. While I go to the other side, Mr. Andy's on this side. All right? And we got the cord on the box. It's okay, it's safe. You can do that. All right? So nobody else does that. We build more safer tools. We build a larger capacity for you to stay safe. Okay? All right. So, Mr. Andy, what I'm going to do is I'm going to use this tool, and I'm going to use this tool safely because I know I got to keep my air dielectric. Don't forget a hat if you didn't get one. Guys, I'm going to keep my air dielectric. Huntsville trains me to take care of her. I'm back on my stick, all right? And what I want you to do is I want you to read the voltage on my foot. Go ahead to 2 kV. Yep, which is your secondary. 1 volt to 2,000 volts, all right? And what I want you to read, can that camera see here, Amanda? Read the voltage on my boot. And let it be to where that camera can catch it. There you go. You go on top of my boot so it's not so difficult. There you go. All right. What voltage do you have, Mr. Andy?
Yes, 1100.
That should
11.
11. Okay. Tell those guys though.
11.
There you go. Make sure you tell them. I can hear you just fine. All right. 11 volts. All right. So I'm working safe. Whenever you all are working safely, you know how your electric reality works. Even though you're working safely, I'm underneath the transmission line. That transmission line is bleeding to ground to some measurable degree, as this distribution line is bleeding to ground to some measurable degree through my body, even when I'm safe. Okay? Go ahead, Andy, get my back. Okay? Tell them. Okay, good. I'll make a tunnel, come to this first glove toward the front by the meter, closest to the meter on the rubber. There you go. What you get?
16.
Let that gentleman see. There you go. About 16?
Yep.
All right. See how that happens? I'm working safe. But let's say that no one's ever taught me these principles. No one's ever taught me these safe work methods. No one's ever explained my reality of electricity. I just assume because I have PPE on, I just assume because I got all this safety training, I got this beautiful truck, a beautiful paycheck, I always assume that short sticking, I'm working safe. No one's ever taught me otherwise, okay? So I'm gonna short stick, okay? Come on, get the same voltage. Yeah, boot, right on top.
20.
Tell them. Okay. All right, back.
23. 24.
Okay. Front glove. Closest to the source. There you go.
43.
See it. Let him see it. There you go. Can you see that? 43?
No, 48.
48. Okay. Now let's go. I'm going to be tool glover. Remember that guy that grabbed a tool with his gloves for years and years and then finally did it without his gloves on? Barehanded.
Foot.
Okay, foot.
90.
All right. Back.
104.
All right. Front glove, closest to the tool.
192.
All right. So about 200 volts. Y'all see that? Now, does that sound like those are safe work practices to you all? Tool gloving, short sticking, those aren't safe. That voltage is going through my body. How do you think that my body's going to look like when I retire by doing these things? You think it's safe that your body is energized with that source that high all the time? You know, what is the doctor going to say about that tumor? Maybe you don't eat healthy. Maybe you eat a lot of packaged processed foods, you know, some sodas. You know, what do you think that stuff does to you guys? Okay, it makes you where your body is, your immune system is not a warrior. And that's the truth. You've got to take care of yourselves because your immune system is amazing. It's a gift as well. So trust it. But in order to trust your immune system, take care of it. Okay? If you don't take care of it, then you might as well not trust it because you ruined it. All right. So go ahead, Andy, read the voltage at that stick. Remember this stick here is insulated. It's fiberglass, 100,000 volts per foot. Go ahead and show them though, not me. They're the audience, buddy, okay?
17.
Now, Andy, if you go home, you're not married?
Not yet.
You got a woman? Girlfriend? All right, if you go visit your woman and she says, show me your stuff, Andy, you don't be showing your stuff over here, away from her. She's the audience. You got to show her your stuff here, buddy. Yeah. All right?
Right.
You okay?
Yeah.
She'll want it. When you ask her to marry you, she'll say yes if you do that. I'm helping you. All right? Okay, come on. Show me that voltage. Go mid-span.
Okay.
Let them see it.
53.
53? All right. Go to the top of that meter.
Top of it right here?
Yeah. You hear a little buzz?
Mm-hmm.
What do you get?
1500 is what it looks like.
1,500 volts. Huh?
1500.
You guys see that? So 1,500 volts. If I take this glove off, and I'm tool gloving, and this one day I take off this glove, and I go to that tool gloving, barehanded, what's going to go through me? About 1,500 volts. I might get hurt. When you're using a corded tool, try to keep the cord away from you about 36 inches as well. Remember the meter, the tool, always consider that tool energized. You're going to try to stay away from it 36 inches. Your cord, when you're using these, if you're phasing, you better not have this cord next to your thigh because it's energized. It's not going through the air, it's going through the cord. If this cord gets hit with a fault potential and you got this cord next to your thigh, you may die. True? Okay? So stay away from it. Train and teach. It's safer than everybody else's cords, but still keep your safe practices. Okay? All right. So Mr. Andy and I here, we're at this left Padmount house, and what we're going to do is we're going to look at phase to ground. The reason why we're looking at phase to ground is we're going to verify the tool's working on a live known voltage source. Remember that? We're going to also verify our phases are energized prior to phasing. You guys know that. That's obvious. We're also going to verify, to me this is the most important, Andy and I are going to verify with each other that Andy is going to verify his head's in the game. He's got my back. New location. We were at the overhead. This is a new job, same day, but we're going to reaffirm that I got to reaffirm to him That's our practice, that I got his back. Just to get us a little check. And we're gonna talk about it. Just check what's going on in your mind at that moment. So we're gonna go ahead and go energized and verify that our head's in the game. And we're gonna always remind each other and talk about it. Because, again, most linemen are getting hurt, or killed, because they're not talking about it and their head's not in the game. All right? We're also gonna go phase to ground on capacitive test points because this meter is so accurate. We're gonna look at the voltage difference between one phase to ground, the other cabinet, or other side of the cabinet, phase to ground, because we know how electricity works. We know that the capacitive test point to ground voltages is gonna be a little different on every elbow because of the location, remember, of the particular elbow from ground, from other sources, from all of our components, right? We know that every elbow has its own fingerprint, its own it's semicon material that when it cures, when it dries, it's a little different than the other elbow that looks just like it. So the voltages are usually a little different, all right? And we know that. So if we're phase to phase in phase, what this tool is gonna show us, it's gonna show us the difference if we're in phase. It'll show us the difference. Do the math, and that gives you the 0, same phase, all right? All right, you ready?
Yep.
Okay, Andy, go ahead to that capacitive test point. That elbow to ground, and tell us what you get. Oh, yeah, you might have to go off and then back to 2 kV. And Miss Amanda will be looking at that number. What you get?
169.
Tell him.
169.
Okay, so about 170. All right. Remember what we talked about if you want to get married or not?
Yeah, I got to show them.
She's over there, bud.
Right.
Pay attention to her.
Right.
She'll never, you ask her, she will say no. You didn't show me your stuff, man.
Right.
Okay. Okay, go to the next one. I'm a great marriage counselor too.
171.
171, there you go. So what, 3 volts difference?
Yeah, something like that.
Really close, but a little bit different. Okay, so I'm gonna go to the other side of the cabinet. All right, and let's see if we're in phase. You ready? Okay, you go to the top, I'll go to the bottom. What you get? Tell them.
1. I get 1.
1. So it's pretty close. Do the math, that's close to 0. All right? All right, good job. And what we're gonna do is we're gonna phase this cabinet. And remember, while we're phasing this cabinet, don't forget that overhead line's close to you, 20,000 volts, okay? So come on in, and I want you to go to that top lug. Go to that top lug, and I'll do all the hard work. Stay there and you let them give them the numbers.
All right.
Show her your stuff.
Yeah.
Okay, you're just getting this now?
Yeah, I'm getting it.
All right, it took you a little while.
Just a minute. Yeah.
Huh?
Yeah, it takes some.
Alabama, is the folks there a little like that?
I guess.
Okay. Okay, you ready? What you get?
118.
Nice, that's good.
Yeah.
All right, stay there. All right, what'd you get?
0.
Same phase? Stay there. What'd you get?
206.
Okay, out of phase. Pretty cool, huh? Let's go ahead, we're gonna phase this overhead line. So what we gotta do is we always have to use the proper accessory, isn't that right? On your tool, right? Proper accessory. And we're gonna run this cord out a little bit, try to keep it a little bit in parallel because this cord is too long for our job situation scenario. This is maybe your grounding cable on your truck reel. You're gonna take that grounding cable on your truck reel and you're gonna roll it out on the dirt, just like this, okay? In parallel. Not gonna be on your truck reel no more. That's what it's gonna look like. And what we gotta do is we gotta use the proper accessory. Andrew, so because we have bushings on this overhead line, it's kind of odd, we got to change out our accessory on our tool. So grab that bushing adapter, change it out. And what we're going to do is, Mr. Andy and I, Huntsville trains us that when we're making an accessory change, when we're making a tool change, or maybe an equipment change, what we're going to do is we're going to take that bucket, we're going to take ourselves underground, and we're gonna get out of that little work area. And we're gonna create capacity to fail safely. And we're gonna take a few steps away from that work area to make the change, okay? So that's what we're doing. And always use the proper accessory on your live line testers. Always use the proper accessory on that cone tip, whether it's a straight probe, hook probe, bushing adapter. And the reason why is because you want to keep from bypassing your resistors. Using the proper accessory is going to remind you of not bypassing those resistors. Maybe it's dark outside, maybe it's foggy, and you can't see very good, a little rainy. Well, the chances, if your depth perception is messed up by these ingredients, you may bypass that line limit more readily. So always use the proper accessory. If you don't use accessory, that's a shortcut. It's unsafe, and you're training others to do it whenever they feel like it too. Okay? So don't do it. All right. So what we're going to do is I'm going to ground. Mr. Andy, you go ahead and get on that long source, that hot wire above your head.
You good to get in there?
Yeah, go ahead. Go ahead and plug it in, man. What do you get?
It says 1.
1. So the tool is telling Andy that he's got the tool in the wrong position. It doesn't hurt the tool. Remember, we were doing phasing. We were looking at potential on secondary. Well, now we're on primary. So the tool, it doesn't hurt the tool if you have our tools in the wrong position. They just give you a funky reading. So go ahead and take it to 25 kV and reinsert. Okay, there you go. All the way in, man. Get it in there. Yeah, you got to be that guy. All right, what do you get? What do you get?
202.
202. It should be like 20,000.
Well, yeah, 20,000.
Okay, 20.2.
Switch things there.
All right, so 20.2. So what I'm going to do, keep it in.
Oh, keep it in?
Yeah, yeah. All right, I'm going to go to the other side of the cabinet. All right, we're going to verify if we're in phase or out of phase. Hear that cord?
Mm-hmm.
What do you get?
0.3.
0.3. So it's not quite 0 because, hear that snapping? That cord has a little bleed in it. There's about a 0.5 milliamp of current that flows through that cord when you're using it, about a 0.5 milliamp, no more than that. And we want to try to stay away from the cord about 36 inches, but the cord's safe. You can use it when it's on the ground. Okay. Now, whenever you're high potting with this tool or phasing with this tool, what you all want to always do is this sequence. We want to always go with the secondary probe to ground first. Always. And the reason why is because when Mr. Andy pulls that tool off, he knows that those resistors on the secondary probe and the meter probe, he knows that it's going to take a few seconds to bleed off that energized source within that cord. So it's going to take a few seconds. But what he wants to do, Mr. Andy, is he wants the tool to tell him that the tool is de-energized and the tool's safe by looking at the numbers of the tool. So he puts the secondary probe on ground first every time. So when you're done phasing. So I'll do that. Phase to ground. Okay, buddy, go ahead and remove that. Did it bleed off?
Yeah.
Okay, cord safe. Or that conductor that you high potted, we bled that charge that's on that cable. The cable's good. We bled the charge off, and the tool's telling us that cable's safe now, and the tool's safe. Both of them. That's another South Carolina word. Both of them. It means both of them. It's one word, both of them. All right, good?
Yep.
All right. Make sure you get on ECOS, guys. You could register. Just email me at safetytraining@Bierer Meters. It tells you exactly what to do. It's really simple. Once you're registered, you get all the videos, all the announcements, everything at no cost, the best of the best. Danny Raines, Jimmy Vaughn, the best safety managers and speakers in the United States doing it for free. Their companies are paying for it, for them to fly to South Carolina and go to our live line training center, and we film it all there. We pay for the videographer, and you get everything for no cost. This is really cool. Thank you, sir. All right, so let's talk some more about this. So you guys have the phasing ranger, the PD800W. What you're gonna do is you're gonna go out in the field and you're gonna phase accurately, map, tag, balance, whatever you're gonna do. So what we're gonna do is the phasing ranger base unit, you're not going to worry about it. This is going to be plugged into a receptacle here, substation, or your home, whatever you guys choose. It's going to have a dedicated phone line that goes to it. It can have up to 5. One base can have 5. All right, so that's cool. You're going to calibrate this, a one-time calibration, to every time when you touch a known A phase out there in the field, your PD800W is going to read zeros and a white light. It's going to be there's a white light that goes solid. It'll go solid. You'll see your screen, the display goes zeros. If it's close to 0, maybe 2 clicks off, maybe 8 clicks off, and you get a white light, it's giving you 2 confirmations it's the same phase. All right? But whenever you use the PD800W for phasing, always take it to the degree setting for phase angle. You're out of looking at potential. You don't want to use it to look at potential when you're phasing. Don't do that. You want to look at the degree angle that's being generated by the generation plant. So remember that. So this is its second function that's totally separate from looking at potential. Totally, it's 2 tools in one. So you're going to put it in degree. And when you touch that known A phase, you're going to see a white light, zeros. That means it's calibrated. You're phasing your base unit. Your base unit is calibrated. You're good to roll. Once that's set, which is easy to do, you all are going to take your line truck. You're going to go underground, overhead, whatever conductor you want to call it. It doesn't matter the name of the conductor. You're going to get to that location, take your cell phone. You're going to dial the phone number that's dedicated to your phasing ranger. You dial the phone number, and you hear beep, 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 and you turn on your Bluetooth on your phone. Make sure your volume's up. Turn the Bluetooth on the phone, and this links up. When you see that white light go solid, that means you got the data from your phone, which it's getting from the ranger, the base unit, and it's going into your field unit. The field unit, when that light goes solid, the field unit becomes your known A phase. This is your reference out in the field at that moment. You could be 300 feet apart from these 2 antennas up to line of sight. Okay, 300 feet apart, data light's solid. Whenever you touch, you make contact with any conductor, whatever the potential, doesn't matter, high side, secondary, primary, transmission, or maybe a receptacle nearby. It doesn't care. If you see a white light and close to zeros or zeros, it's an A phase. If you see a blue light and you're close to about 120 or it's 120, that's a B phase. Red light, you're seeing about 240 or close to it, that's a C phase. It's real simple to use, all right? And depending on leading and lagging power factors in the field, it could be below 240. You might see 232. High pot. You all do any high potting? Do you? So do you know about our battery operated high pot? Okay, this is another tool you all can trial, Joel. It's a battery operated high pot, uses 18 volts Milwaukee. You guys use Milwaukee, correct? Correct? Makita, Milwaukee? Makita? All right, we can do Makita as well. Either platform. Do we just change out the base? All right, so we can do Makita, and what happens is you're gonna have your cable de-energized, isolated, and you're gonna be on a feed through, and let's say we got a dip pole over here, we got another transformer over here, and we're on a high pot to that dip pole, and we got a feed through. We're gonna make sure everything's de-energized. If you approach and that horn goes off, it means it's sniffing something. Verify you're de-energized. If it doesn't go off, that's a good thing. You're on your hot stick, plug it in. You're gonna turn on this switch, turn it on, that needle shoots up. This 18 volt battery puts 8,000 volts DC on that cable. If the cable's good, that needle goes back down and stays down. If it's a very long cable, that needle could stay up maybe 10%. And it's just telling you it's a long cable, it's got a little bleed on it, but the cable's good. All right, if that needle goes up and stays up, that's a bad cable, or if the needle bounces, that's a bad cable. Okay, real safe, you don't have to have an AC source around. Just use this, it's very safe, okay? Partial power flickering lights, do you guys do that? Do you know about our ST800? Oh my gosh. So this is what I call a must-have. If you're a troubleshooter, this is a must-have tool. Caroline, you can set this up for them to have next week and let them trial it. But go to the video. This does 5 functions. I don't have a lot of time to talk about it. got a little psychological safety at the end I want to bring up. So this tool does 5 functions. One, it sources up to 800 amps. No one comes like a tenth. A super mega beast, I think they do like 80 amps. This does times 10 that. So you got to have this tool. You're using 800 amps. It's a 4 millisecond pulse that you're testing your secondaries, hot legs, and the neutral to the source. It'll let you know which one's bad. If it's in the clear, you'll see the sparks and you'll hear it popping because it's high magnitude pulse, okay? So this is must have. We got bigger clamps if you're doing any commercial or blade work, all right? The other thing it can do and does do is with the STRCV receiver, service test receiver, this picks up the pulse so you can now identify your conductors if they're not labeled properly at the source. Maybe you can't read the labels anymore and you want to take one of those cans, one of those customers out of service and work on their service, keep the other customers in. This picks up the pulse so we can identify both hot legs and the neutral with the receiver. Okay, so now we can ID secondaries. Two functions. The other function that this can do is we can identify positively the feed out and the feed in at the pad mount with the same tool. Also with the same tool, additional with the CT clamp right here that plugs into the back of the ST800, now we can identify primary cable in the ditch and manhole, energized or de-energized with the same tool. That interconnect cable plugs in right here. Now you get 2 more functions. Now we have 5 functions. No one can do that, okay? One of our Walther's patents is this tool. Okay, I think you guys have the 3-phase ID tool for cables. Do you? Do you guys ever see it from underground? Maybe you guys don't have it. So what this tool does, well, this is a must try out tool too. What this tool does is it puts, we got our cable isolated, de-energized. We got a couple manholes in between, and we're in this ditch over here, or another manhole. And we want to ID our A, B, and C phase. You keep everything in between bonded. Don't have to lift nothing, because it has enough power to go through all those grounds. Fine. And we're going to get on the center conductor, feed throughs, elbow clamps, C clamps, however, alligator clips, and we're going to put 1 pulse on A, 2 on B, 3 on C. Very simple. We developed this for Eversource several years ago, and it's another patent. It's a good tool. So you can see here, C in here, 3 clicks, that's a C phase. There's 1 click, that's an A phase. 2 clicks, that's a B. Very simple to use, very safe. You guys could trial this. We got a video on this, how to use it, all right? You probably only would need 1 in this in your system, just 1. Just sign out for it. Someone else needs it 2 weeks from now, you have it, and you sign out for it, and you bring it back to that 1 location so other folks can use it, okay? If you only need to identify 1 phase, take 2 of these leads off, you got 1 phase identification ability, or all 3, okay? It's a good tool. All right, and you guys could trial anything, and we got more, but we can't talk anymore. So one more thing I gotta bring up is psychological safety, okay? So you guys watch football sometimes, probably got some teams you like, or maybe you don't like, either way, and line work is basically a lot like football. It's a lot like football. And what it is we are all Huntsville Utilities. You guys are a football team. All of you guys are 1 football team. Underground, overhead, troubleshooters, you are 1 football team. And this team is made up of the CEOs, it's made up of Mr. Andy, it's made up of everybody in between. The lead linemen, journeyman linemen, the supervisors, the foremen, whatever you guys want to call yourselves, that's our team, all right? And the idea of this team that you guys are, Huntsville Utilities, is you want to win the game. Every day when you guys go out, it's not that you want to win, but you have to win. You're going to win the game. And you can win this game every single day. But in order to do this, you've got to stay focused. You've got to be dedicated, and you got to be in it to win it. You got to be disciplined, and you got to practice, right? Do we not practice? A good football team practices all the time. So you guys practice to prime proficiency. You guys practice for things that are totally unexpected. The worst case scenarios. Maybe Mr. Joel, he comes out to the job site and he says, hey, guys, this is what just happened. Andy, he just got hit. He just went down. What are we going to do about it? And you guys practice. And he's on the ground. He's unconscious. He got hit some primary. Who's calling 911? Who's trying to resuscitate him? Who's making sure he's comfortable? What are we doing at this scenario? And I guarantee you, if you practice running through these things twice, even 3 times before Mr. Joel leaves the job site, you guys by the 3rd time will be pretty ready for something like that to happen. Not only that, but practice primes for proficiency. When you practice for these worst case scenarios, guess what? You expect, you can predict, and you prepare, and they never happen. They never happen. Because you know what to expect in order for this worst case scenario to take place. You practice it did happen, well then you can prevent it now. You can predict these things. You see how that works? So this football game, everybody's in the stands watching. This football game is comprised of an audience, like your girlfriend, okay? And she is cheering you on to get home. Your wives, your children, they're all in this audience and they're cheering you guys on to get home. But in this audience is also those who want you dead. They want you to lose the game, okay? Everybody that you've known in the past that has been birthed in these bodies, everybody in the past, let's go back 200 years ago and further, every one of them died. Yes or no? Yes or no?
Yes.
Yeah. Okay, so we live in a matrix of death. This body, not you, your spirit, your soul, not that, but your body lives in a matrix of death, and your body's going to die. So in that audience is death. And in that audience, death wants you to lose the game, and death wants you to get hurt. If he can hurt you, that's fine. Lose an arm, that's fine. He goes home happy after the game's over. He's happy. And then you got the opposing team, right? The opposing team wants you to lose the game. But in order to win the game, you have to control the ball, right? You have to control the ball. When you're on offense, that ball is on your side. In other words, your consciousness. When you control the ball, your consciousness, that ball, your mind, is on your side, and you're winning the game. When the defense has it, what happens when the defense has your ball, you're thinking of politics. You're thinking of debt. Maybe you got in too much debt because you weren't controlling the ball, and you lost focus, and you thought things were going to make you a better person and happy, and they don't. They don't make you happy ever. Things. What's that? Okay? And when the defense has the ball, maybe you're distracted by something. Maybe someone yelled at you and you're distracted. Well, the defense has the ball. The defense has control of the ball, your consciousness. You don't even know it. The opportunity to lose the game is much greater that day when the defense has your mind. Do you guys get that? You may lose the job if you're not thinking of what it means to have that ball in control. The waterman, maybe you have a water boy on your team. The least of the least. The gentleman that was cleaning the janitor that was cleaning the bathroom is doing a superb job, by the way. He's part of this team too. Everybody. The ladies that work the desk. Where your check is generated from, the person that makes that happens. We're all part of this football team. And that ball has to be in control of one another on the offense side. Y'all get that? Okay. So 10:30?
10:29.
Okay, one more story. All right, 1 minute long. All right, so several years ago, there was 2 linemen working together as a team, and they were changing out a broke pole. They knew the conductors above were hot. There was no doubt they knew it was hot. And one of the guys was a journeyman lineman 20 years. And they were friends, they were buds. They did things together, they hung out together, they talked about life together. And they're on this job site. And his buddy, the 20-year journeyman lineman, his buddy was working the boom. The boom made contact with the conductors above. At the exact same moment, the 20-year journeyman lineman was in the truck gathering gear. And for a split second, he became a ground plane. He became a ground for that boom, that potential that boom came in contact with, came through, instantly came through, boom. And in a split second, his wife lost her husband, the kids lost their dad. Okay? So let me ask you guys a question real quick. On that job site at that moment, the guy that was working the boom, was he mutually accountable to the 20-year journeyman lineman that just lost his life? Was he mutually accountable on that job site? Was he? He's dead. He didn't know where he was. He wasn't paying attention. So he was not mutually accountable at all. He was 100%, he died. Now let me ask you a question. The guy that was the 20-year journeyman lineman was friends with the guy working the boom. Do you think that he would want his friend to have that weight on his shoulders, that he's no longer here, but that weight is on his shoulders for the rest of his life, that he gets to see his kids grow up, he gets to see his kids get married, he gets to have dinner with his wife and family and friends for the rest of his life. But on his shoulders is the fact that his friend, because he wasn't watching him, didn't have his back, he's no longer here on this earth enjoying his family. So was the guy that was the victim, was he mutually accountable to his friend? Because now his friend has that weight on his shoulders. He wasn't. See? It works both ways. The victim, those incidences that happen, the person that was involved in the incident, not watching the victim's back, he becomes the victim as well. See? And everybody loses the game, because you got to be mutually accountable. You got to know where each other's at. You got to know where the equipment is. You got to know where the conductors are in relation to everything. Yourself, your other equipment, your grounds. You got to make sure that you're looking at every possible path to ground when you guys are setting up your EPZ. You know, you're working on a conductor and you know it's de-energized. You know that for a fact. Did you take your time to set up your grounds in case that conductor, for whatever reason, became re-energized? Are your grounds set up? Or you just want to do this quick today? No one's around. You know, no one's looking. Last February, was it February? I was at SCE, Southern Cal Edison, and I was doing safety training with those linemen, and that was hard. The customer calls and said, hey, you got a guy here laying on the ground. That's a true story, just last month. That was hard, man. It's hard to do safety training after an incident happens, and I've got to see those guys face to face, because they're hurting. And we got to do a better job. We got to watch out for each other better. Make sure you don't shortcut on your grounds, all right? This is so important. All right, guys, this is it. Hope you guys enjoyed. I need a couple guys to help me pack up. Don't forget your hat. I got line stickers if you guys want line stickers. And get in ECOS. Get Huntsville into ECOS. There is no cost to ECOS. Okay? Any questions? Good? All right.
Appreciate it.
Yeah, thanks guys.